So let's take a look at finding vertical and horizontal asymptotes and removable discontinuities, or better known as holes. So number one asks to find the horizontal asymptote and vertical asymptote for the function y equals 3x to the fifth minus x squared over x plus 3. So it's probably easier to start with the horizontal asymptote because all we're looking for is the highest degree of the numerator, which is 3x to the fifth, and the highest degree of the denominator, which is just x, or x to the first. And since this is top heavy, meaning the highest degree on the numerator is bigger than the highest degree on the denominator, then there will be no horizontal asymptote. So no horizontal asymptote. Instead, what there will be is a slant asymptote, and to find that slant asymptote, you can actually long divide. So just divide the top by the bottom. But really what we're looking for is end behavior, and so you can actually divide the highest degree of the numerator, so 3x to the fifth over x, and you just get 3x to the fourth. And if you plug in like something in like infinity, or a really large number, so you get 3 times infinity to the fourth, it'll just give you infinity, which tells you that the function will go to infinity as the x values increase. Now, in order to find the vertical asymptotes, we have to make sure we completely simplify the function. And I mean, we could factor out an x squared for the numerator, but that's not really gonna actually simplify anything from the top and bottom. So we can just leave it as it is. But in order to find the vertical asymptote, once we simplify completely, we have to set the denominator equal to 0. So I can just say x plus 3 equals 0. And if I take the 3 to the other side or subtract 3, then x will equal negative 3. So at x equals negative 3, there is a vertical asymptote. So number 2 asks to find the horizontal and vertical asymptotes for y equals 4x squared minus 1 over x squared plus x minus 6. So once again, I'm going to start with the horizontal asymptote, and all we're looking for is the highest degree of the numerator and the highest degree of the denominator. So we have on the numerator 4x squared as the highest degree, and on the denominator x squared is the highest degree, or 1x squared. So notice how the coefficients and the degrees are the same, x squared and x squared. So all we have to do in this case, if the degrees are the same, are just look at the coefficients of the highest degree. So the highest degree, or the highest coefficient, the coefficient of the highest degree on the numerator is 4, and the coefficient of the highest degree on the numerator is 1. And 4 over 1 is 4, and we have a horizontal asymptote at y equals 4. So now, in order to find the vertical asymptotes, I'm going to have to simplify the function as much as possible, and I can actually break up the numerator and denominator into different factors. So 4x squared minus 1 is actually a difference of squares, so I can break that up into 2x plus 1 and 2x minus 1. And x squared plus x minus 6. I need two numbers that can multiply to negative 6 and add to a positive 1. And that would be x plus 3 and x minus 2. So if I were to rewrite the fraction here, I'll get y equals 2x plus 1 times 2x minus 1 over x plus 3 times x minus 2. Now there isn't really anything to cancel on the numerator and denominator, so now all we have to do is find the vertical asymptotes. And once again, we set each factor equal to 0. Because if one of them equals 0, when you multiply 0 times the other, it will still equal 0. So we have to say x plus 3 equals 0, and x minus 2 equals 0. So for x plus 3, if I subtract the 3, x will equal negative 3, and if I add the 2, then x will equal 2. So there are vertical asymptotes at x equals 3, or negative 3, and at x equals 2. So number 3 asks to find the horizontal asymptote, vertical asymptote, and the whole or a removable discontinuity for y equals x squared minus 25 over x cubed minus 6x squared plus 5x. So starting with the horizontal asymptote once again, we just need to look at the highest degree of the denominator and highest degree of the numerator. So on the top we have x squared, and on the denominator we have x cubed. So now when it's bottom heavy, or when the function has a higher degree on the denominator, then the horizontal asymptote is actually going to be at y equals 0. Because if we simplify x squared over x cubed, we just get 1 over x. And if we plug in infinity for x, we get 1 over infinity. And as the x values increase, or get bigger and bigger, we eventually get to 0. Or we never touch 0, but that's the limit. So now in order to find the vertical asymptote and holes or removable discontinuities, we need to be able to break up the fraction. So x squared, I'm just going to rewrite x squared minus 25 and x cubed minus 6x squared plus 5x. So in order to break up x squared minus 25, this is actually like the previous problem, difference of squares. So I can just put x plus 5 times x minus 5 as the two factors, because when they multiply they equal x squared minus 25. And starting with x cubed minus 6x squared plus 5x, I can actually start out by factoring out an x. So when I do that, I get x squared minus 6x plus 5. And x squared minus 6x plus 5 is a quadratic, and I can factor that out as well. So I need something to multiply to get me 5 and add to get me negative 6. And the two factors would be x minus 5 and x minus 1. So I gotta take what I found in the numerator, the x, and what I found in the denominator, and rewrite my fraction. So x squared minus 25 can be simplified as x plus 5 times x minus 5. I have the x here on the denominator, and then I have x minus 5 times x minus 1. So notice how the x minus 5s can cancel. And when you have terms or factors that can cancel at the numerator and the denominator, that's where you have a hole. So I can set either the top or the bottom equal to 0. So I can just do x minus 5 equals 0. And when I add the 5, x equals 5. So there is going to be a hole at x equals 5. And so if I want to find exactly at what point on the graph there is a hole, I can actually simplify this fraction. So I can remove the x minus 5s. And then what I can do is plug in the x value of 5. So I get y equals x plus 5 over x times x minus 1. And when I plug in 5 to this equation, I'll get 5 plus 5, which is 10, over 5 times 5 minus 1, which is 4. Then I get 10 over 20, which is equal to 1/2. So at the x value of 5 and the y value of 1/2, so I'll rewrite it as the coordinates of 5.5. There's going to be a hole in the function, or in the graph. So now in order to find the vertical asymptotes, all I have left to do is set the denominator equal to 0. Or in other words, I can set x equal to 0 and x minus 1 equal to 0. So x equals 0 is already solved. So we know there's going to be a vertical asymptote at x equals 0. And x minus 1 equals 0, and when we add the 1, we get x equals 1. So also at x equals 1, there is another vertical asymptote.